So in this video, we're wrapping up this chapter talking about geometric series. Remember, a series is, all we're doing is adding all the members of a sequence. So here, just like we saw for arithmetic series, we had a rule for arithmetic series, we've got a new rule for geometric series. Here, S represents the sum up to a given nth term. A sub 1 is the first member in our sequence. R is our common ratio, and then obviously N is whatever position we're stopping at. So let's plug in what we know in example 22. So we want to consider this series. Obviously, this series, the very first position, A sub 1 is 1. I also need to find my common ratio, so I'm going to do a little bit of scratch work. So 5 divided by 1 is 5. We're told it's geometric, so I don't need to keep going because I know that it's going to be the same all the time. So this tells me that R equals 5. Now, in part A, I'm asked to find up to the first n terms. So that means n equals 10. Okay, so now I have all the information I need, and so that means I can plug in. So S of 10 is going to be my first position, so 1 times 1 minus my common ratio of 5 to the 10th power, all over 1 minus 5, close parentheses. Now, we can type this in our calculator exactly the way it is, but we have to make a few modifications. So first off, I have more than one thing on the top, so I need to put that in parentheses. Also, more than one thing on the bottom, so I need to put that in an extra set of parentheses. Be sure you include the red parentheses on the outside. So let's go to the main screen and do this. Clear it out. So 1 parentheses, the purple parentheses, 1 minus 5 raised to the 10th power. Close the purple parentheses, divided by purple parentheses, 1 minus 5, purple parentheses, and close the red parentheses. And we get 2,441,406 is equal to S of 10. So that S of 10 represents the sum of this series up to the first 10 positions. So that's our answer for part A. Now, we could have also done this in our calculators, but what we would have had to do is first to create a rule for the geometric sequence. So that geometric sequence would be A sub n, which is equal to our first position, so 1 times our common ratio raised to the n minus 1 power. Now, when we do this in our calculator, instead of n, we're going to use x. So let's do this. Again, we're starting in the first position and going all the way to the 10th position, so keep that in mind. And so what it's going to look like in our calculator, we're going to say sum, sequence, and then we're going to use our rule, 1 parentheses 5 raised to the parentheses x minus 1, comma x, comma 1, comma 10. Again, this piece right here represents our geometric sequence. X is for the variable that we used. 1 is because we're starting in the first position of our series. And 10 is because we're adding up the first, we want to stop at the 10th position of our series. Let's type that in our calculator and see if we get the exact same sum. I hope we do. So clear it out. I'm going to go second stat, math, option 5 for sum, second stat, ops, option 5 for sequence. Type in our rules. So 1 parentheses 5 parentheses raised to the parentheses x minus 1, comma x, comma 1, comma 10. Close parentheses. And I get the exact same number, 2,441,406. Now, in your notes, you had a part B. I decided to throw part B out because it's just way too hard for this class, and I didn't realize it until I tried to do it myself. It can be done, it's just way too much work, so don't worry about part B. If you want to cross it out in your notes, you can do that. But that wraps up this chapter. We talked about sequences in series in general, we talked about arithmetic sequences in series, and we talked about geometric sequences in series. So, if you got questions, please let me know.